Here we're going to look at example 4, complete the square to solve a real-world problem. We're told that Libby plans to create a rectangular pasturing enclosure, and she has 340 meters of fencing available for the enclosure's perimeter and wants it to have an area of 6,000 meters squared. So those are going to be kind of key things. All right, 340 meters of fencing and 6,000, an area of 6,000. What dimensions should Libby use? This problem is not always the easiest type of problem. Usually you kind of have to figure out where to go with your equation one step at a time, and sometimes you really just figure out things along the way once you've seen things written out. All right, so I'm going to start with a rectangle with length times width, and the two formulas I know are that perimeter is 2L plus 2W. It's a terrible W. And the area is equal to length times width. Now I know that we have 340 meters of fencing, so that's going to be my perimeter. And I know that we want an area of 6,000 meters squared, so that's going to be my area. So at least I know what P and A are in this case. What I'm kind of hoping for is that I can use these two formulas to create another type of formula, most likely a quadratic because we're being told to complete the square. So I do need to find some kind of quadratic here that I can use the completing the square method. So my perimeter would be 340. Again, we're going to substitute that in. We're being given that information. Equals 2L plus 2W. And we're told that the area is equal to length times width. But let's stick with the perimeter for a second. With these problems, you always want to isolate one of the variables. It doesn't really matter whether it's the length or the width. In this case, I'm going to isolate the width. So I'm going to subtract 2L from each side. So we get 340 minus 2L is equal to 2W. Divide everything by 2. So 170 minus L is equal to W. Now, why did I do that? I just know from these type of problems that I'm going to want either width or length isolated. The ultimate goal here is to get an equation that only has widths or only has lengths, and we'll see how that plays out in a minute. Now, we know that width is equal to 170 minus L, so I'm going to go back to my area formula this time, and I'm going to say that 6,000 is equal to length times width. But now I know that width is equal to 170 minus L, so I'm going to replace that. So 6,000 is equal to length times 170 minus L. And now here, I have an equation that only has one variable, okay, L. It's there twice, but it's just the same variable. So that's a really good sign that I am on the right track, and I will probably be able to solve this. I have one equation, one variable. We are in good shape. So let's move that up here. So 6,000 is equal to length 170 times 170 minus L, sorry. I'm going to multiply these in. Again, this is kind of from the type of problem I know I'm doing. I know it's a completing the square, so I'm going to want a quadratic. So I'm going to multiply these terms. So 6,000 is equal to 170L minus L squared. Definitely not the prettiest problem or the prettiest equation to work with, but we'll make it happen. So moving forward, 6,000 is equal to, I'm going to switch these two terms. I'm going to put the negative L squared term first because that's your, basically your AX squared, remember, plus BX plus C. So you want that X squared, that quadratic as the leading term. I do not like that the leading term of the quadratic is negative, so I'm going to divide everything by a -1 so that I can change that. So negative 6,000 equals a positive L squared minus 170L. And now that's much better for me. Once again, because it is a completing the example, complete the square example, I now know I'm going to use b over 2 squared. I'm looking for this term here. Okay, what is going to be that term to make a perfect square trinomial? So let's find some colors to use here. My B term is negative 170. Let's write this in red. So we are going to do negative 170 divided by 2 squared. That would be negative 85 squared. And then 85 squared would be, or negative 85 squared would be 7,225. So to create a perfect square trinomial, I am going to add 7,225 to each side of my equation. The negative 6,000 plus 7,225 is going to give us 1,225. And then if I factor this, I kind of cheat here. 7,225 came from negative 85 squared. So that means I can use 85 as that term in there. And then we're going to square that. Or actually, let's write that twice. Let's not take any shortcuts. And now I can write that as L minus 85 squared. Now that I've completed the square, I have here an equation that I can solve using square roots. So take the square root of each side. The square root of 1,225 is 35. That works out nicely for us. So we have positive negative 35 equals L minus 85. Now we're almost there. We can create our two equations. L minus 85 equals a positive 35, and L minus 85 equals a negative 35. So we're going to wind up with two solutions here. If I add 85, I get L equals 120. And if I add 85 here, I get L is equal to 50. Okay, so I have a possible length of 120 and a possible length of 50. We always want to make sure that our answers make sense. Lengths should always be positive, so at least they're positive. That works for us. Since I have a perimeter of 340, if either one of those were greater than 340, or actually even greater than half of 340, I would have a huge issue. But they're smaller than 340, they're positive. That means I'm probably in good shape right now. Now we need to find the width. So we're asked what dimensions. So we know that the length is 120 or 50. So let's find the width. Our width is equal to, from our earlier work, 170 minus L. So W will be equal to 170 minus 120, or 170 minus 50. Okay, so again, we have both of those options for L. So W would be equal to 50, or W is equal to 120. Now, notice that the width and the length are the same to each other. So it's either 120 and 50 or 50 and 120. They're the same thing. All right, which one you make the length and the width is kind of arbitrary. It doesn't really make a difference. So what dimensions should Libby use? Our rectangle is going to be 120 by 50. If I do 120 times 50, we should get 6,000, which we do. So that's a really easy check because you need to make sure the area is right. And if I was to add up these sides, 120, 120, 50, and 50, I get 340, which was the perimeter that we had. So we should have one side, or how do we want to phrase this? I guess not one side. Let's kind of phrase this a little more carefully. We're going to say that Libby should make it so that two sides of the enclosure are 120 meters and the other two sides are 50 meters. So two sides are 120 meters and two sides are 50 meters. There we go. That'll be the solution. Again, not the prettiest problem in the world. Definitely not something that we are looking forward to on a regular basis. But it's nice to see that you're able to use completing the square in kind of different settings, not just a mathematical setting where it's been specifically set up for that. You can apply it to some other scenarios and things that can be used in the real world. And in this case, you're trying to find, the dimensions of a enclosure. So hopefully this makes sense. Try not to look at it as a giant problem. Look at it as individual steps. Go piece by piece. Anytime you're dealing with a rectangular enclosure, use both the perimeter and area formulas. You'll either wind up using both of them or one of them, but it's always a good idea to write them both out and see which one, and in this case, both of them, are going to help you get to your answer. It's also really good to be aware of the method that you're being asked to use. So I mentioned it a couple of times. We're doing completing the square. So I know that I needed to create a quadratic at some point. And the only way for me to do that was to isolate a variable and then create an equation where I only had, in this case, the variable L. So it's good to have some background. It's good to keep asking yourself, what do I have and where am I trying to go? And instead of looking at the entire trip, just look at one step or one direction or one turn at a time.